Welcome back to Space Reviewed. I'm Andy. My next review is on this unassuming looking satellite. Its name is Fengyun 1C, and it's a Chinese weather satellite. Measuring the weather is one of the biggest things that satellites do for all of us on a day-to-day basis. They track clouds, sense rain, detect temperatures, and take other measurements that make our weather forecasts much more accurate. In this image, for example, you can see the clouds over the UK and Europe, and separately see where it's raining and how intensely. But if I'm honest, this review is not really about Fengyun 1C's work as a weather satellite. It's more about what happened when the Chinese military pointed something a bit like this at it. In 2007, China launched a modified ballistic missile topped with a special sort of warhead targeting Fengyun 1C. Space might have seemed far away from terrestrial conflict, safe even. But the reality is that militaries around the world know that space-based systems are powerful, and they've worked on ways to lessen that power from the very beginning of the space age. China's test of an anti-satellite missile threw this reality into sharp relief. It also created a big mess. This is a chart showing the number of satellites in orbit in purple, and the number of other things, debris, in blue. You can see a sudden leap in 2007 caused by the shrapnel from Fengyun 1C. Over time, this debris slowly falls back to Earth and burns up in the atmosphere, but even today, about 20% of the debris in orbit came from the Fengyun 1C incident. The amount of debris up there is a problem for satellite operators, because they need to avoid crashing into it. Tracking the debris, predicting its movements, and deciding on any necessary evasive maneuvers is a big challenge. That's illustrated by the next big jump in debris on the chart, in 2009. That was caused by a collision between an inactive Russian military satellite and a commercial communications satellite. The satellites were being tracked, and the commercial satellite's operator had a warning of the potential for a collision. But the errors in the measurements meant that the calculated probability of the collision was low, not even the most likely collision on the day it happened. So they didn't try to move out of the way, and unfortunately, the collision happened. There are two other much smaller jumps in debris on the chart, which you might be able to see if you look really closely. Between the two big ones, there's a tiny jump from when the US shot down one of its own spy satellites. Because the satellite was very low down when the missile hit it, and because the operation was carefully planned, not much orbital debris was produced, and what was produced fell back to Earth pretty quickly. Similarly, right at the end of the chart in March 2019, a test of an Indian anti-satellite missile created a small amount of debris. Again, although the test was condemned for creating debris that crossed the path of the International Space Station, it was carefully planned to minimize the problems it caused. It's not just missiles that people are using to take out satellites. There's a big role for more novel approaches. Directed energy weapons are attractive for this purpose, both lasers and radio frequency weapons. This image is actually of a US laser used to measure how far away satellites are, but China is investing in lasers as anti-satellite weapons. NASA has actually looked at lasers too, as a way to solve the problem of space junk. They've suggested using a laser to remove debris from orbit. There are other approaches to removing rubbish from space. This image shows a system from a company called Astroscale, which uses a magnet to latch onto a piece of junk, the satellite on the left then acting as a kind of space tug to pull it out of orbit. The problem is that these systems could also be used to remove active satellites in a conflict. We need to worry about international adversaries pulling UK satellites from orbit. But we also need to worry about those same adversaries thinking legitimate UK civilian clear-up activity is actually hostile to them. There's a potential for misunderstandings that could be dangerous. So, Fengyun 1C, as a weather satellite, great. Who doesn't love weather satellite? But as the target of the first anti-satellite missile test, it was the source of about a fifth of all debris currently in orbit, and it paved the way for future anti-satellite weapon tests to make even more debris, and generally make space a less safe place. That's a pretty big negative. I give Fengyun 1C 1 star out of 5.